Okay, today's lesson is going to look at something called empirical formulas. So I'm not covering the entire 7.4 section. I'm actually going to break it up into 2 days. So we're going to focus on defining what an empirical formula is and how that applies to ionic and molecular compounds, and then determine an empirical formula from either a percentage or a mass composition. And then tomorrow we'll look at the relationship between empirical formula and molecular formula of a given compound, and then how do you write or determine a molecular formula from that empirical holy smokes. Determine a molecular formula from an empirical formula. So we're just going to look at the first 2 learning objectives today. All right, take a look at these 2 molecules here. We have a nitrite ion, NO2 with a -1 charge, and dinitrogen tetroxide, right? So compare and contrast these 2 molecules. Well, looking at it, you can say, okay, the molecule on the right, it has 1 more nitrogen than the molecule on the left. It's got 2 more oxygens than the molecule on the left. So basically, it's a doubling of it, right? The shape of these molecules are different. Here we have angular and bent, and I wouldn't really know how to describe the second one. We see they both have double bonds, but the one on the right has more double bonds. So those are all pretty good comparisons as well as differences. But really what I want to focus in on here is the number of atoms in the molecules differ, but that ratio between nitrogen atoms and oxygen atoms is the same. So remember I said that the molecule on the right is like a double in, like you kind of like double a recipe. Well, you can simplify N2O4 to NO2 because both of those subscripts, the 2 and the 4, right here, are divisible by 2. And when you take those numbers divided by 2, then you get NO2. So empirical formulas, thank you. All right. So empirical formulas, which I'm going to abbreviate EF, show composition of a compound in its simplest ratio. Okay, so if I'm looking at ammonium nitrite, NH4NO2, it's a 1-to-1 ratio. Okay, so here I have NH4NO2. These are my hydrogens. These are my nitrogens. These are my oxygens. Okay, but I can simplify it. Nope. I don't know where I was going with this. This is embarrassing. Oh, yeah, it is. It is. Okay, sorry. The ends are throwing me off. So this is really N2H4O2. I can divide all those numbers by 2 and simplify it to NH2O. Sorry about that. So this is the empirical formula, and this was the actual composition. Now, in ionic compounds, the formula unit is usually the empirical formula. So remember, formula units are the simplest ratios of ions in an ionic compound. Well, if it's the simplest ratio, it's most likely going to be the empirical formula. For a molecular formula, something that's held together by covalent bonds, the empirical formula does not necessarily indicate the actual numbers of atoms present in that molecule. So, for example, if I'm looking at a compound B2H6, I can simplify this by taking both these subscripts divided by 2. So 2 divided by 2 is 1, H6 divided by 2 is H3, so I can simplify it by 2BH3. This would be the empirical formula. This is the molecular formula. So how do you calculate empirical formula? These are the 3 steps, and I have them color-coded because on the next slide I'm going to use my interactive pens and I'll color-code it. So the first step is convert the mass percents that they give you for each element and convert them to grams. So every percent that you see, you're just going to say, okay, that's how many grams I have of that element. So you're just going to assume you have 100 grams total of that compound. Okay. Step number 2 is you're going to convert grams to moles by using the molar mass of that element. So you're going to take your grams that you're assuming that you have, and you're going to divide it by the molar mass. And then you're going to compare the amounts of moles to find a whole number ratio. Basically, you're going to find the lowest number of moles and divide everything else by that number. And if that seems really confusing, well, let's move on to the next slide and do some examples and clarify that. So I just need to remember the colors here: purple, green, blue. Okay, so let me get my purple pen. So it says a chemical analysis of liquid shows that it's 60% carbon, 13.4% hydrogen, and 26.6% oxygen by mass. Calculate the empirical formula of the substance. So step number 1, if I go back, convert mass percent of each element to grams, and just assume you have 100 grams total. So I have, for carbon, 60.6%. Well, we're going to assume that we have 60.0 grams of carbon. And hydrogen, I have 13.4%. So I'm just going to assume I have 13.4 grams. And for oxygen, I have 26.6%. And I'm going to assume that I have 26.6 grams. Okay, sorry, that's a decimal there. Connect that 6. Okay, that's step number 1. Yay, we're 33% done. Moving on to step number 2, convert grams to moles by using molar mass of each element. So I'm going to change my color here to green. So I have 60.6 grams of carbon. So I'm going to take this number and divide by the molar mass of carbon. And I get the molar mass of carbon by looking at the periodic table. It's the pink number on my giant periodic table, and it's 12.01. So when I take 60.0 divided by 12.01, I get 4.99 moles. Okay. This is supposed to be grams per mole, because the grams will cancel out. Hydrogen, 13.4 grams of hydrogen. I'm going to take it divided by its molar mass. Molar mass of hydrogen on my periodic table is 1.01. So 13.4 divided by 1.01, I get 13.26 moles. And finally, oxygen. I have 26.6 grams of it divided by the molar mass of oxygen, which is 15.99. And I get 1.66. Oh, guys, come on. Sorry. I was supposed to write 15.99 there. Go me. All right. So divided by the molar mass of oxygen, which is 15.99 grams per mole. And when I do that, I get 1.66 moles. All right, now if I go back for the third step, okay, so we've done that, we're 66% done. Compare the amounts of moles to find the whole number ratio. Find the lowest moles and divide everything by it. So looking at these three values, 4.99, 13.26, and 1.66, which one of these is the lowest? And you'll say, hey, this one is, okay? So you're going to divide all the other numbers, every single number I should say, by this value, this 1.66. So when I take 1.66 divided by 1.66, I get 1. When I take 13.26 divided by 1.66, 13.26, sorry, divided by 1.66, I get 7.98. And when I take 4.99 divided by 1.66, I get 3. Okay, now when you take a look at these values, these numbers need to be very close to 1. Or to a whole number, I should say, not 1. They need to be very close to a whole number. And if you look, they are. I mean, 7.98, technically, when I typed it into my calculator, I got 7.987. So really it's like 7.99. So these numbers here represent the subscripts below it. So my answer is C3, because look, there's the 3 for the C, H, this is really close to 8, and then O, and it's just 1. So the empirical formula based on these percentages is C3H8O. Isn't that incredible? Just from a bunch of percentages, you could figure out the empirical formula. I don't know about you, but I think it's pretty cool. All right, let's move on to another example. Change my pen to green. A dead alkaline battery is found to contain a compound of manganese and oxygen. Its analysis gives 69.6% manganese and 30.4% oxygen. Let's find the empirical formula. So the first step is you're going to assume that whatever percentage you are given for each element, that's the number of grams you have of that element. So for, where's my pen? Where'd it go? Lost my pen. Okay, there we go. I already messed up. I was going to write Mn. That's okay. Okay, here we go. Mn. So I have 69.6%. We're going to assume that I have 69.6 grams. And for oxygen, I have 30.4%, and I'm going to assume I have 30.4 grams. All right, there's the first step. Okay, the second step. Change my pen here. I think it's purple is next. Or maybe it was supposed to be purple, green. Oh, it's supposed to be purple. Oh well. I think I can fix this. Okay, it's fixed. Oh, brother, green. Okay, so percentage, you assume that's how many grams you have. Second thing, we want to convert grams to moles for that element. So 69.6 grams. You're going to divide it by the molar mass of manganese. Manganese on the periodic table is element number 25, and the molar mass is 54.94. So I'm going to take this number and divide it by 54.94 grams per mole. So 69.6 divided by 54.94. I get 1.266. I'll just leave it at 0.26 moles. Same thing here with oxygen. I have 30.4 grams of oxygen. I got to convert it to moles. The molar mass of oxygen on the periodic table is 15.99 grams per mole. So 30.4 divided by 15.99 equals 1.90 moles. Now of these two numbers, which one is the lowest? And you'd say, okay, the manganese, the top one there. So I'm going to divide every other number by that value of 1.26. So if I do that, 1.26 divided by 1.26 is 1. 1.9 divided by 1.26, I get 1.5. Okay, now we got a little problem here. Okay, it's not, that value 1.5 is not close enough to a whole number. However, I could multiply everything by 2 to get that to a whole number. Okay, so if I multiply 1.25 by 2, now what do I get? 3. That's a whole number. But because I multiplied this value by 2, that means I also have to multiply this top number by 2. So 1 times 2 is 2. Now do I have whole numbers? Yes, I do. So your answer for this one, manganese 2, O3. So this was a great example for when you don't get a whole number. Now, what would happen, instead of having a value of 1.5, I got a value of 1.33. Then what would you have to multiply it by to get to a whole number? And I hope you're thinking, well, geez, I'm going to have to multiply that by 3, right? Because like 1.33 times 3, well, now it's going to equal 4, right? And now I have a whole number, and then I have to multiply the top number by 3. Okay. Let's take a look at another example here. Purple first. Analysis of 10.150 grams, sample of a compound known to contain only phosphorus and oxygen, indicates a phosphorus content of 4.43333 grams. What is the empirical formula of this compound? So here we're not given a percentage. We are given mass. And here is the total. Okay. And here is just phosphorus. So for this one, we can figure out the percentage, and then from percentage go straight into the steps that we've been doing. Okay, so I'm going to change my pen color here because this isn't really a purple step. This is something new. So if you're ever given mass and they're asking for the empirical, well, you got to get to percentage, and then you're just going to jump into the 3 colored steps that we've been doing the last 2 slides. All right, so I have 4.4333 grams of phosphorus, right? And if I take this number divided by the total amount of the sample, 10.150 grams, I'm going to get a percentage of phosphorus. So 4.4333 divided by 10.150, I get 0.436778. Okay, that's good enough. This is not a percentage yet, okay? So let's multiply it by 100 to turn it into a percentage. 43.6, I'm going to round up, 8% is phosphorus. Now, this compound only has phosphorus and oxygen, so can I figure out my percentage of oxygen? Absolutely, because this value, P plus oxygen, has to equal 100. Okay, percent. That's supposed to be percent E. Okay, so to figure out O, I'm just going to go 100% minus 43.68%. So 100 minus 43.68%, I get 56.32%. And that, my friends, my students, that's oxygen. That's percentage of oxygen. So now I have my percent for these 2 elements, and they do indeed add up to 100. So I'm going to change my colored pen here. Go to purple, and I'm going to move this out of the way. So phosphorus, the percent is 43.68%. So we're going to assume that I have 43.68 grams. And oxygen, 56.32% to 56.32 grams. Oh, I lost my pen. Okay. Change colors here. Step number 2. Convert the grams of that element to moles of that element. So I'm going to take 43.68 grams divided by the molar mass of phosphorus. Phosphorus on the periodic table is 30.97 grams. So 43.68 divided by 30.97. I get a value of 1.41 moles. Oxygen, the molar mass of oxygen, 15.99 grams per mole. I should have wrote mole up here. So 56.32 divided by 15.99 is 3.522 moles. All right, so I got my two numbers here. Change pens to blue. We're on the straightaway. Which one of these two is my lower number? The top one is, so I'm going to divide all my values by it. So that's going to be 1. And then 3.522 divided by 1. Type that in again. 3.522 divided by 1.41. I get 2.49. Oh, crumbs. Shoots, that's not close enough to 1. But I can double this number and get to a whole number. So if I take this times 2, I get 4.99, which is pretty close to 5, so I'm just going to write 5. And I multiply the bottom number by 2, so that means I got to multiply the top number, or all the other numbers, I should say, by 2. So I get 2. So my answer is phosphorus 2, because there's that 2, and then oxygen, and there's 5 of them, diphosphorus pentoxide. All right, so there was a great example there where I was given mass and I had to get to percentage, and then I just jumped right into the 3 steps that we've been doing for these examples. All right, let's do one more, and then that's it for today. Magnetic iron oxide is 72.4% iron and 27.6% oxygen. So first step, assume your percentage to grams. So iron is Fe. 72.4% means I have 72.4 grams, and oxygen 27.6% means I got 27.6 grams. That's the first step. Second step, convert. Oops, wrong pen. Oh, geez Louise. Bam. Okay. Convert grams of your element to moles of that element. So you do that by dividing by the molar mass. The molar mass of iron, number 26 on the periodic table, is 55.85 grams per mole. So 72.4 divided by 55.85. I get a value of 1.29. Oxygen. Molar mass of oxygen is 15.99. So 27.6 divided by 15.99, I get a value of 1.72 moles. Change my pen here to blue. Almost done. Which one of these two numbers is my lowest? This top number, so that means you divide everything by that value. So this is going to be 1. 1.72 divided by 1.29 is 1.33. We were just talking about this like 2 sample problems ago. I don't have a whole number here, but I can multiply this. How many times to get to a whole number? I can multiply it by 3 to get to a whole number. So 1.33 times 3 is 4, or really close to it. But because I multiplied this number by 3, that means I also have to multiply all the other numbers by 3. So the empirical formula for this, iron 3O4. Yeah, all right. So that is empirical formulas. You do have a worksheet. It's single-sided. I think all of them, except for one, are percentages. So you're given the percent and you just jump right in and you just assume the number of grams. But then the final one is they give you mass and you have to figure out percentage and then jump into the 3 steps. Okay? All right, I hope this was helpful. Again, if you have any questions, you can bring them tomorrow for class. But that does it.